I'm supposed to tell you that you're on a hot mic.
Oh, great.
So,
I won't say anything bad about Mark.
no.
Sorry.
I'm supposed to be doing an. Can you hear me? I don't know.
Hello, hello.
How long have you been on the hot mic?
I don't know. I'm glad they told me. You better want to use the restroom before I.
Oh, yes. I want you figure yourself again. Warm up speech.
Pizza, 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 pizza. Thank you to Beam for all the pizza.
Yeah.
Hot mic, she told you. Right?
Mm-hmm.
So don't say
Probably hear me chewing.
Don't say anything controversial.
Okay.
Hello, everybody on all the places. We are just grabbing some pizza. Sorry you're not here to join it, enjoy it with us, but we're gonna grab some pizza, kind of hang out a little bit, and then Brian's gonna get started. So, yeah, that's it. See you in a few minutes.
And that's it. All River Point people.
You're very modest.
Do we want to turn that on? I guess. Is there a? Assume there's a remote somewhere.
Oh, great! Everybody's gonna listen to us go through our technical difficulties.
Well, a lot of those will turn on when they get a video. Yeah. Screen mirroring. It's like at work, like we can't get the video conferencing to work half the time. We're like,
I mean, I work here, but I work in my house. So
Right, yeah.
I'm here in this office.
I guess let's keep this in here.
Okay. Well, I guess we'll get started. Thank you guys all for showing up.
I was going to say thanks for sponsoring.
Yeah, thank you to our sponsors.
Yeah.
Cassandra, would love to give you a minute just to say your thing, and
Yeah.
I'll introduce Bryan.
Thank you. Yeah. Cassandra Ferris. I'm a product strategy technologist here at Veeam. Right now I'm focusing on kind of the Azure and Veeam integrations and learning Azure myself. So I've been around the cloud community for a long time, but never a practitioner. Bubbles up food. Drinks are in the break room. Please take some swag home if you'd like it. And I'm going to pass around the sign-in sheet. Please sign in so my accounting people won't yell at me. And that's it.
Cool, thank you.
Awesome.
If I was a recruiter, I'd be like, and we're hiring.
Yeah.
Thank you, Cassandra, and thank you, Veeam and Cassandra, for taking time out and sponsoring this event and hosting, being a wonderful and very generous host. Thank you guys so much. I'm delighted to introduce our speaker, BK Bryan Krausen. You guys might have seen him from Udemy. He does courses on all the things.
All the things.
Like we were just talking about all the new courses he's got in the works across the technology spectrum, and really delighted to have somebody your caliber come down to little old Columbus, Ohio. So thank you so much.
Actually, I came up.
Yeah, coming up to Columbus, Ohio.
Louisville. Like I live just south of Louisville. Yeah.
Yeah.
So not too bad.
Yeah. So he braved the airports.
I actually flew in only
Yeah.
because I was going to drive, but I have to be in Boston tomorrow. And so I ended up flying so I can fly to Boston because I wasn't going to drive from Louisville to there to Boston to home. So,
Yeah. Quite the globetrotter.
Yeah.
But
Yeah, only because I had to be in Boston tomorrow.
How long is that flight? I mean, you get up and you come down. How did you get out?
Well, there's no direct, so I had to go through Charlotte. It's like, yeah. But it's only like an hour flight for each one, so it's not bad. Yeah, but yeah, if it was direct, it would be like a 30-minute flight, maybe.
he's getting his money's worth out of that lounge pass.
Yeah,
like you
exactly.
gotta have connections to make that thing worth its money, right?
Yeah,
yeah. But yeah, thank you so much.
Yeah.
I have never worked with Consul before, and I don't know if we've ever had a Consul presenter at the Columbus Hug. So I know we've seen some Vault and definitely some Terraform and stuff, but I'm very excited to hear you talk, and I'm looking forward to learn. So
Awesome.
thank you, Bryan.
Cool. Yeah, thanks for having me. I appreciate it. It's been a while since I did a hug. I used to do, actually a while ago, I was doing hugs everywhere. I was like Minneapolis, Charlotte, Raleigh, like all kinds of different hugs, but it's been a while, so I was super happy. I've been trying to like do more hugs because honestly, like part of my role, so I work for a company called Riverpoint Technology, and part of my role is not only consulting with customers, but it's also like more of like evangelist, technical evangelist, speaking in front of customers, those kind of things. So, so this is something I've been wanting to do for a while. So as soon as Mark posted it, I'm like, hey, I'm volunteering, you know. And yeah, so happy to be here. So yeah, today we're going to talk about consoles. You guys know anything about Consul, what it does? You do? Okay, awesome. Anybody else? No? You guys know HashiCorp? Obviously. So this deck actually came from one of my courses, and so I kind of put it together. This is a picture of me if you don't know what I look like.
Look at the matching shirt.
I know it, yeah. I do this for all my courses, so I just stole it from there.
He doubles as a male model.
Right. Principal technical, that's kind of old. My title now is like VP Technical Evangelist, but so my role is kind of a split role. I still work with large companies on a consulting basis, so I'm kind of assigned to like 2 very large companies right now. Both are large Vault engagements that I'm working on. One's a disaster, which we're trying to fix. One's a big migration project from Azure into GCP. Sorry, Mark. Where Bardstown, I don't know if you've heard of Bardstown, it's where all the bourbon is made. So I live in the middle of like all these distilleries and all that kind of stuff. And I don't even drink bourbon. I always get crap for that.
So much temptation.
Yeah. Why? The why is really just like why I started like training and teaching and those kind of things. So like, you know, going through IT, I've always had kind of a passion for education, like teaching others. Like, you know, a lot of this stuff, like I had to learn the hard way, and I'm like, this is dumb. No one should have to learn it the hard way, right? So I try to make it easier. And I've been working with Consul for probably over 5 years now. My start with Consul was actually because of Vault. So like way back in the day, when you're deploying Vault Enterprise, HashiCorp said, you have to deploy Vault Enterprise, you have to use Consul as the back end, right? And they give you a free enterprise license, but you had to know Consul if you're gonna run Vault. Now nobody uses Consul, or I'm helping people get off of Consul as the back end for Vault. But so that's me. 2 links real quick. This is also for my course. GitHub, BT Krausen is me, and then I do have a repo out there, HashiCorp. I have a lot of stuff for HashiCorp, obviously, out there. So there's stuff for like Consul, Nomad, Terraform, Vaults, all the things out there. btk.me/btk, that's my own URL shortener. That just goes to this, right? And that's like, you know, the special repos where you have, you know, like your README, and it's just like, you know, about me. I have links to all my courses and stuff. This is just an example of some of the courses I have. This is actually one of the ones I was bragging. I'm like, oh, all my best stuff is bestsellers out there. But so just an example of some of the courses that I have out there. Not asking you to buy it, but I'll give you free passes if you need it. But so I do have training courses on almost all the HashiCorp products, and I'm doing a lot more other stuff like Kubernetes, AWS, GitHub, certifications, all that good stuff. So anyway, all right, cool. Let's get into what we came here to talk about is Consul, right? So obviously you know all of the HashiCorp suite of tools, right? You know, we know Nomad for, you know, containerization and scheduling, Vault, Terraform, all those good things. Getting a phone call. Nope, won't be answering that. But here we're here to talk about Consul, right? So the idea behind Consul is really around, the industry's kind of like pegged the term service mesh, but HashiCorp's kind of taken a step back from service mesh, and service mesh is really a feature of Consul, where Consul really focuses on like networking, you know, between services within your organization, right? So you think of, you know, how do services communicate with other services within your organization? Consul takes care of that, right? So you can do it through like DNS or API, but it's really about networking, you know, within your infrastructure, and not networking like Cisco switches and IP addresses, but how do we communicate, you know, apps between each other, right? So some of the key features of Consul, we have service discovery, which is really like the core functionality of Consul. Without proper service discovery, like none of the other stuff is going to work very well, right? So you have to get service discovery right before you can use a lot of these other things. Service segmentation, what services can talk to what other services, right? As we're talking about, like moving all these monoliths, which I always get ahead of myself. I got slides for all this stuff, and I have way too many slides, and we'll bust through them pretty quick if you guys are getting bored. But service segmentation is how do services talk to each other, right, or not talk to each other if you don't want to talk to each other. Service configuration, that's really just like what HashiCorp terms like their distributed KV store with Consul. So Consul really provides a distributed KV store. that you can store basically anything, any kind of key value there. And service mesh, really, it's kind of integrated in there. They do have community, which I just updated the slide a minute ago. And instead of calling it open source, it's community now. So console community versus enterprise. So community is actually very feature rich, right? There's a lot of stuff you can still do with community across the board. Service discovery, again, the foundation of everything in console. Segmentation through what's called intentions, layer 7 traffic management, KV. You got mesh gateway. There's like 4 different types of gateways now with console mesh gateways. I forget them off the top of my head, but there's a bunch of others. Application-aware intentions, things like that. And when you get over to enterprise, you get a lot of the other fun stuff that you would need for an enterprise, like automated backups, which I think that's the dumbest thing HashiCorp does. Is automate back, like really, I can't automate the backup of my infrastructure when you're using your tool. I have to buy enterprise, but I think that's dumb. Automated upgrades is not what it sounds like. Automated upgrades is really like, okay, I'm going to upgrade my cluster, and I'm going to do it in more of a, oh gosh, sorry, what's it called when you add nodes in there instead of upgrading in place?
Like maybe like a canary deployment or blue-green or?
Yeah, kind of like blue-green, where you're adding, you're basically adding nodes or replacing nodes instead of upgrading in place. You're provisioning new nodes, and that just kind of helps with that. You have admin partitions. You can actually break out console, so you can give parts of console to different folks within your organization, and they only see those parts of it. That's similar to like namespaces as well. Sameness groups is something like fairly new. We'll mention that when we talk about peering. OIDC, audit logging, right? These are kind of features of enterprise. All right, so why use console, right? In your organization, you've got probably tons of different applications, right, running on different stacks. You may even have these applications that are running on different types of platforms, whether they're VMware, Pivotal, OpenShift, or even where they're running, right? They may be running on cloud, they may be running on premises. Console has the ability to connect all that together, right? Because console is completely platform agnostic across the board. So you can have clusters that are peered between GCP and AWS and on-prem, VMware, running all these different types of apps. That's a huge benefit of console, is it's totally platform agnostic, where other ones like Istio and things like that, you basically have to be running Kubernetes, things like that. The problem, one of the problems that it tries to solve is this migration of apps from monolith to microservices, right? So we know what a traditional monolith looks like, right? We've got traffic coming in, probably through a firewall. We've got individual nodes that are hosting multiple parts of an application, right? And then through a firewall and through some other DNS. The problem is if one of these apps goes down, basically the whole thing goes down, right? So we have to kind of replace that, and that's why a lot of folks are moving to more like a microservices architecture. And so we've got all these different microservices that are broken out. It also gives us the ability to choose service-specific databases as well. And so when we start breaking out monoliths into a microservices architecture, right, it may look like something like this, like we're deploying multiple instances of each microservice, out there. But a lot of these microservices, they need to integrate and talk to each other as well as talk to the database, right? And so it may look something like this. And so you may have, you may want to, you want to allow or disallow some of these services from talking to each other, right? So you may want, things like, the search service you may not, oh, I'm going the wrong way. You may not want the search service to communicate with the payment service, right? So you can't accidentally search for credit cards or, those kind of things. So, so that's what one thing console kind of helps address is, not only communication between all those services and even external services, right? So these could be living on physical servers or in the cloud or whatever. But how do you permit or deny some of these services from communicating with each other, right? So some of the core features of console, so kind of touched on this earlier, dynamic service registration, meaning that when services are launched, whether they're containerized, VM, on the cloud, whatever, they can automatically register themselves with a service catalog that console manages. And then we can use service discovery for those services to communicate with each other, right? So we have the ability to communicate or discover services through either DNS calls or we can just make API calls to console to discover like, okay, who are my healthy nodes for the search service, for the database service, for whatever. Distributed health checks. So we don't have console. We typically, when you deploy console, we have a console cluster. Well, the console cluster itself isn't responsible for health checking everything, right? It's not like a traditional load balancer where you set up all these health checks and like, hey, are you healthy? I'm going to take you in and out, if you're based upon certain health checks. The agent itself that runs on the individual services as more or less a sidecar, it does health checks on itself basically, and then it reports back into console saying, my service that you told me to check is healthy, right? Or it's not healthy or whatever. And so you have this distributed health checks across all the nodes, so you don't have the console cluster itself responsible for those checks. I mentioned the centralized KV storage, so just plain, whatever keys, values I want to store up there, but it's centralized, so you can have all your apps like come to console, right, to get that data. That KV storage is also replicated across all the nodes within the cluster itself as well, so it's distributed across all the nodes. So if you have 1 or 2 nodes go down, the KV storage is still available. You do have ACLs to protect, everything in console. So, who can do what, inside of console. You also have like OIDC to perform more your authorization, or this is authorization, your authentication, and you have ACLs for more your authorization. Segmentation, we'll touch on that around using intentions. So service A can talk to service B, but not to service C. Cloud, I mentioned this before, cross-cloud and data center availability. And of course, we have, just like any HashiCorp product, API, UI, and CLI interfaces to do all the fun stuff that we need to do with it. So the first thing we'll talk about is service discovery. I said it's kind of the pinnacle of everything that console does. If you don't get service discovery right, nothing else is going to work very well for you, right? So the idea is that you have this central point of contact, which is console in the service catalog, for all services to register themselves with, and then for all services to go find other services they want to communicate with. Typically today, without service discovery, it's like DNS, right? I need to go, I'm going to put a friendly DNS name in there. It's going to point to a load balancer, which is going to distribute to other services, right? And then that load balancer is going to do the health checks, right? Console can take a lot of that stuff out, right? So it's really handling kind of your east to west traffic versus north to south. Service register is really important for dynamic workloads, right? So such things as containers that are coming up and down relatively quickly. When containers can come up, they can register themselves with console. They can say, hey, I'm service A, I'm healthy, I can accept traffic. Console's like, cool, I'm gonna start, I'm gonna add you to the pool, right, and start sending traffic there. When it goes down, it stops sending traffic there, right? So it's pretty cool because it can automatically register itself with console, and then it'll dereg as well. I mentioned reduction, elimination of load balancers, right? Console starts to perform that magic for you, right? You can do things like round robin, you can do traffic splitting, you can do all the things you can do with load balancers. You can do that, handle that with console, right? Because now it knows where all the services are, and you just call it by name. It's going to point to the correct service, a healthy service that's providing that service for you. Real-time health monitoring, as I mentioned, distributed responsibility throughout the cluster. So all the individual agents that are deployed on the nodes, they are responsible for health checking the services that they're supporting. And you have basically node level and application. So is the node itself healthy, right? Is the CPU spiking? Is those kind of things, or is the application itself is the port open that the service is running on, right? So you have 2 different types of health checks. So if you have like a node level go down, like every application that's registered itself on that node basically becomes unavailable, right? Because like the node is down or something like that. But you can have individual application level health checks as well. So what does it look like? We've got console cluster up here in the middle. I like doing animation because I feel like animation kind of tells a better story than just words on a slide. So you got your console cluster up here, and you got 3 services, as part of our microservice architecture, right? Inventory, search app, order app, right? Every time you launch one of these, right, you have the console agent, and it's not required on everything, but if this is like a traditional VM or a physical server or something, you're gonna have the console agent running as a sidecar on the application server itself. This is actually the same exact binary that's used to run the server, except for you just run in agent mode instead of server mode. So when these come up, they're going to automatically register themselves with Consul, right? Hey, I'm the search service, I'm the order service, blah, blah, blah. Consul inside of its service catalog is going to register those. Okay, cool, I've got one node of each, right? So if the order service needs to communicate with search service, right, we ask Consul. And when I say ask Consul, it can make a direct API call, or it could just query DNS, right? And then within our infrastructure, we've got, maybe the order server, say if this is like a traditional VM, the DNS servers may point to our DNS servers or traditional, but we have like forwarders to say, okay, if you're looking for something .consul, go to Consul servers to discover where that is, right? So again, we're also sending health status up to Consul as well. So again, DNS queries, API requests to find other services. We can even support external services, right? So these will be like external services that may not necessarily be able to run the Consul agent. We can still point to these. So you think about things like, I'm an AWS guy, sorry Mark, but things like DynamoDB or S3 or other services that we're using on any cloud that we can't necessarily go out and deploy the Consul agent and have it communicate directly with our cluster. We can still register those external services, and so this order service may still be able to communicate with the database service through Consul because we can register external services like that as well. And because of that, we can still manage like who can talk to it. Right? So if the order service says, hey, I want to talk to this database service, if we have an intention that says order service can't talk to the database service, we're like, okay, sorry, we're not going to let you talk. Right? That's not a firewall per se, but the order service will actually use a proxy to communicate, and the proxy will basically refuse that communication. Right? So when we go and talk about intentions, you'll see how we can do that to permit or deny services from talking to each other. Now, as we scale out individual services, right, we're going to scale out inside of our service catalog. It's going to know that, hey, now we have 4 instances of the search service, 3 instances of the service inventory, and it's going to register those in the service catalog. And then whenever the order service needs to communicate with one of these, it's going to start doing like round robin or traffic splitting, or it's going to load balance in a sense between all those nodes. So again, this is where the load balancer replacement comes in, is Consul's taking care of that for us. All right. Scale a lot of nodes, yeah. So automate networking security by identity-based authorization, right? So no more IP-based firewall security. I think this is a draw out too. Yeah. So say we've got a Golang service, we've got a database service, right? Traditionally, when we stand these up, they're going to have IP addresses, and we need to go into the firewall and say, okay, this service needs to communicate with this server over 3306, right? So we would do that, on a firewall. Then if we start scaling that out, like, oh, you know what, now we need to go back and we need to add another firewall rule to allow 20.55 to communicate, with this service, right? And as we continue to scale out, it gets worse. Now if we add like database replicas, like, oh, now we got to add the replica in case we fell over, these servers can communicate with the replica, things like that. It's kind of a pain in the butt, right? And we start adding DR, blah, 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 it gets more complicated. And we add Kubernetes, it gets even more complicated, right? With Consul, what we can do is really simplify that, and we can do everything based upon identities, right? So as the Golang service comes up, it registers itself with Consul, says, hey, I'm the web service, right? Database says, cool, I'm the database service. And it registers itself with Consul. Now, what we do in Consul is we say, you know what, the web service can talk to the database service in Consul using intentions. Now, when we start scaling out, all the other nodes are going to register themselves, says, you know what, I'm also the web service. I'm also the web service. Me too. I'm the database service as well. Well, we don't have to do anything inside of Consul because we've already told Consul that the web service can talk to the database service. So it doesn't matter how many times we scale this up and down, right? These services, as long as they register themselves with the proper service name, and we have to have, like I mentioned, ACLs, they have to have tokens in order to be able to do these kind of things. But as long as they register themselves with, as that service, they can communicate. We don't have to worry about those firewall changes because Consul is going to take care of that for us. Yeah.
So do they basically use like some sort of private key or certificate to ensure that there's no impersonation, like if somebody inadvertently or purposefully tried to?
Yeah, that's where the ACLs will come in. That's where the ACLs will come in. So typically what you would have is you would enable ACLs, and these services would have a token. And that token on the back end has sorry, Julie's calling me again. These services on the back end, or the token would have basically a policy attached to it. And the policy that would be attached to this one would say, you are allowed to register the database service, and that's it. Like this server wouldn't even be able to register itself as the web service because it wouldn't have permission to do so, right? And so the idea is that you would really ultimately hook Consul into Vault, right? And then you would have these things like authenticate to Vault get a dynamic console token that gives them the permission to do this thing, right? And then that console token dies, and you kind of get into a zero trust architecture there where like this token only lasts, the Vault token, or the ACL token that was obtained by Vault only lasts for, 5 minutes, 10 minutes, half an hour, whatever. And every time that I need to register or make a change to console, I have to re-register and re-authenticate with myself and get a new token to do that, right? So you're kind of never trusting this guy unless he can identify himself through, through console and if you don't use, or through Vault, and if you don't use Vault, you can just perform, have tokens and things like that to do that as well. But yeah, so they need the permission to do these things. And yes, there's also TLS is also involved in a lot of this stuff. And when I talk about the service mesh specific configuration, you'll see where the TLS comes in more play in there. Multi-DC, so this is a slide I actually created for one of my HashiConf presentations, I think. So it supports multi-DC, right? So we can have a console cluster, an Azure, and a console cluster on AWS, a console cluster on Azure, and they can be peer. They used to be called Federation. The Federation is still supported, and I'll talk about that. But now, like, kind of the new hotness is peering. We're getting away from Federation. But again, in AWS, we can have our applications running over here. We can have our applications running in Azure, right? And so if I'm a cool user, and by the way, I used to use these little emoji guys for all my courses. I don't use them anymore, but that's why they show up. So if I have a user that needs to communicate with this specific service, right? So it's going to make a request. So that request is going to make a DNS query for the MongoDB, and then then that allows this service to communicate with the MongoDB service because it was able to use service discovery to figure out where it is, right? And then obviously the app works correctly, right? So that obviously means intentions and all that kind of stuff are working, but we really focus on service discovery at this point.
But is that like is the traffic actually getting routed through console, or is it
no? Console's not
more of like the matchmaker.
Think of it as like a glorified DNS at this point. Okay. That's all it is, right? It's not really in the data path. Okay. It's just telling you where things are.
Gotcha. So you would still need some mechanism for authorization at the endpoint for that thing.
Yes. Yeah. Okay. Yeah. Absolutely. Yeah. But console does get into the data path in certain, especially on the Kubernetes. Especially when we start talking about like mesh gateways. I cannot think of the other gateways off the top of my head, but like I said, there's like 4 different types of gateways, but those actually get put like in the path. And so, but normally in this stage right here, just typical service discovery, like it's not in the path. It's since like, tell me where this thing is. Cool, I'll go talk to that that service, right? Give me the IP address. It's my responsibility to go talk to that service, based upon the IP and stuff that you gave me, right? And so, again, the service can talk to Mongo because console told it where it was. But if this service the Mongo database happens to go down, right, we have the ability to do peering or federation between different console clusters. Now, each one of these represents like a console cluster, right? So that may be like 3 to 5 nodes, in console in each data center there. So in this event, the application makes a request to console. It knows that, hey, this is down, but this one is still up, right? And so we can actually respond back to the client and say, okay, this MongoDB is down, but this one is actually up. So it actually go across, cross cloud, communicate with this Mongo service, and then the application continues to run, for the user. We just did a big thing. So like I said, I work for Riverpoint Technology. We're like the only consulting company that has like all the competencies for HashiCorp. And we just did one probably in like, I think it's October or something for the networking competency, and it's all about, console and stuff. And so it's like, basically it's, we spent like a month prepping for it, and we had to do basically a 4-hour, we get drilled by HashiCorp for 4 hours on like, do you know this thing? We have to present it, and actually has some slides and stuff in here from it. Any of the Kubernetes stuff in this deck is from that. But so we basically we did what I just showed you right here, except for we just used 2 regions in AWS, but we did it all through more of a GitOps approach. So we had EKS running on both sides. We use Argo, so everything was all pushed through code. We pushed it to a repo. Argo deployed console on both sides, peering, deployed our apps, on both sides, set up intentions, set up sameness groups, all those kind of things. So this exact scenario works perfectly, right? We went and purposely like failed, like the back end we have a little app we call like the Riverpoint hotel app. It looks like, you're booking a hotel. It just has a front end and a back end. So we purposely like failed the back end here and immediately like, showing HashiCorp like refresh, but it never went down, right? Because it started communicating with this service to the, on the other region. So that was pretty cool. So service mesh. So that was kind of service discovery, right? So service discovery, again, service catalog, services register. Consul understands where services are within your organization, understands which ones are healthy, what services they're providing, all that good stuff. Now, service mesh runs on top of that. It requires service discovery, right, to work, because basically what it's going to do is going to really enable a secure communication between services that may not originally be secure, right? You may have services within your organization, like, okay, they're within our four walls. Maybe we don't need TLS between these guys, right? We don't care about TLS between multiple services because we trust our own network. They're behind 10 firewalls, blah, 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 right? Maybe you want them to be, but you don't want to go through the process of having to re-architect the application or, adding more, load balancers and all that kind of stuff. And so this is where service mesh really comes in, and you can use service mesh to enable secure communication between applications, and the applications don't even know what's going on at all. They're just like, hey, I'm reaching out to the same service I was doing it before, but now there's a layer in between that's doing all the encryption, it's doing the it's enforcing the intentions and all that kind of stuff. And that layer is really a sidecar, right? So there's a sidecar. Most of the time you see it as an Envoy proxy, which is like transparently handling all those inbound and outbound connections. So that sidecar is going to run alongside of your application server, right? And if you're running like on a container, it's going to run inside the pod. So you're going to have two containers inside the pod. You're going to have your app, and then you're going to have your Envoy sidecar in there that's going to manage that. And this is basically, there is a new way on Kubernetes that you don't have to use the sidecar architecture. I forget what it's called off the top of my head, but this is typically what you'll see is sidecar, especially when you're talking about service mesh as a whole. Because we're adding the sidecar in here, the sidecar can start communicating directly with Consul, right? So the application, again, doesn't know, it just thinks like, hey, I'm going to talk to my database service, right? But when we say, where's the database service, you actually say like, oh, it's at the sidecar, right? It doesn't know, it thinks it's talking to a database service. It's actually talking to the Envoy sidecar, right? And the Envoy sidecar can now enforce like mutual TLS, between these applications for encryption and authentication. It can also communicate directly with Consul to say like, okay, I'm the web service. Is the web service allowed to talk to the database service? So I can actually check Consul through the API and look for intentions and say like, okay, it is allowed, and then it will broker that communication. If it's not, it won't broker that communication. It will deny that request, basically. And I got some drawings in here so you can kind of better visualize what it is. So we get Consul. Again, we've got 5 different microservices that are registered, all part of like an e-commerce site, right? That register themselves as part of the service catalog. Maybe you want the web service to communicate with all these different microservices within the e-commerce site, but maybe you don't want some to communicate with other microservices, right? This is where kind of your intentions come in. So inside of Consul, we would specifically say, we do not want the search service to communicate with the payment service, right? And we can have default allows in there or default deny. So like, okay, if we don't have a rule, obviously it's like a firewall, right? So it works top down. If there's not a deny, then we're going to allow it. If there's not an allow, we're going to deny if we have kind of a default deny rule. So those are intentions, and they're service specific. You call out, I want this service to talk to this service, or I do not want this service to talk to this service, right? So how does that actually happen? So again, we've got our individual services here, running our application, and now we're adding this Envoy proxy as a sidecar. Again, this could be a VM, it could be a container, and what happens is, it popped up over there. Consul, you can either have Consul be a CA, so it has the ability to be its own CA, so you can just enable Consul to be like a certificate authority and issue TLS certs. Most people are not going to do that. Most people are going to integrate that with an existing CA, so Consul can communicate with a Microsoft CA using Vault, right? Vault's PKI secrets engine as a CA to issue these certs. But now all these Envoys, we're going to issue certs basically out to all these Envoy proxies, right? Again, the application has no idea that this new layer exists, right? We don't have to make any changes. Say any changes. The only change you have to make for payments is like, okay, payment's going to talk here. Instead of saying, oh, shipping is here, you say shipping is here, right? You point it to the proxy, and the proxy handles communication with any of the other services. So using the certificate authority, we distribute mutual TLS certs across the board, right? And so now you have communication directly with Consul when you're trying to find a different service. So if the web service is trying to talk to the search service, we're going to make that DNS call or API call up to Consul, right? Consul's going to say, cool, it's over here. You see my little dot, I don't know if you saw it go up. The web service really communicates with the Envoy proxy. The Envoy proxy validates that it has an intention, and then the service really goes from Envoy proxy to Envoy proxy, and then ultimately brokers that to the search service, right? And again, if you don't have intentions that allow that, then at this stage, it won't permit that communication across the board there. Again, cool that the apps have no idea that all this is going on above it. Any questions on service mesh? I know I kind of blew through it, but really it's focused on, I think I have another slide that kind of talks about the components of it. Let me see how far it is. Network automation, we'll just talk about network automation. I know I have some other slides around that kind of lay out the components a little bit more. Yeah?
So, say for example, if I'm adding a new service into the overall architecture, and it has to say that I'm not allowing any, say, out of the 4 services, only 1 is allowed. Is that intention or ACL being sent to the Consul server, or is deployed as part of the Envoy?
You would configure that inside of Consul, right? So as like an admin, right? You would go in and like the UI supports it, the CLI, everything supports it. So you would actually create a list, almost like a firewall, again, create a list of what can talk to what. So as you're deploying new services. But the cool thing is, like, as I mentioned before, say if you don't want payments to talk to shipping, you just have to define that one time, and I can have 1 million payment services if we're scaling up, and it's still none of those 1 million can talk to the shipping service. I don't care if I have 100 here, right? None of these can talk to these because that one rule says this service, all the nodes that are registering themselves as a payment service are not allowed to talk to shipping, right? And again, it's not a firewall, right? So if someone were to breach this box, they can communicate directly, right? Unless you did firewall it off, right? Consul wouldn't protect that. But typically, if these are secured, then we're specifically talking about regular communication between services, as intended. That's why I don't like it. Personally, I don't like when Hashi says, you can get rid of your firewalls. I'm like, I don't know, because it's not going to stop somebody from, if someone breaches this, service mesh is not going to prevent somebody from going from here to here directly, from server to server on ports, right? It's not going to stop that. But it will stop your traditional traffic that we trust going through, communicating.
There is one point on that, though. You can make the service, not the Envoy sidecar, but the service only listen on the local Ethernet port, not the Ethernet port, the local host.
Mm-hmm.
So it doesn't. The service itself doesn't accept any external connections. It only accepts things from Envoy, and Envoy is enforcing.
Yeah. That's a great point. Yeah. So when I mentioned applications really don't know what's happening, you don't have to really refactor the app, but there are slight changes where you say okay, payments, instead of listening on an IP address here, it's actually listening on 127.0.0.1 over 8,000, right, or something like that. And the proxy actually is listening on 20,000. So you say when payment says okay, I need to talk to any of these others, Consul really it really says it's right here. All those services live right here, right? It doesn't know. It's just that's an IP address. It's a 127.0. It's an IP address. It's a valid IP, right? And a port. So it actually goes right here, and then the proxy handles that communication.
So HashiCorp is somewhat right in the sense that you sort of can get rid of your firewalls if you architecture it right, because the only way that your example container payments talks to shipping, even if they sort of get on there, they can't actually talk to the shipping app. They can talk to the Envoy sidecar running on the shipping.
But I mean, if you get root access to the server, you don't care about this or this. You care about going from this box to this box to this box. Things like that, right? You don't care about running port 80. You care about hitting 22 over here. You care about other ports that are more important to you to breach other services within the org. But yeah.
And it reduces the surface area, right?
Yeah, absolutely.
But Envoy is it's not just an outbound, connection from Envoy, right? Does Envoy, the proxy, actually open an inbound port?
Yeah.
Yeah, it does. Yeah, so it's listening on a port right here for inbound requests.
So,
yeah.
Yeah, because on Azure we have something called Service Bus, which kind of pokes that hole through an
Yep.
outbound connection.
Yeah.
Handshake, and then you don't even have an inbound port open.
Right. Yep.
That's good to know.
Yeah, very similar. Yeah, and on Envoy is like it's not just like passing traffic in and out. Like Envoy is it's a very popular proxy. So not just like in a service mesh, but a lot of people use it. So it's very capable proxy. So there's a lot of stuff you can do with Envoy. With like traffic splitting and routing and all those kind of things. It's pretty complex. But the cool thing is when you deploy Envoy with Consul, when you start configuring a lot of this stuff, the Consul agent will actually create the Envoy configuration file for you. And so when you start Envoy, there's already a config for you that is needed to serve this particular service there. So it's pretty neat. You gotta have the proper config for Consul, but it will, when you start it, it will actually drop a config file, and then when Envoy starts, you have your config exactly what you need to for this architecture.
Cool.
Yeah.
Any other questions? Okay.
Yeah, I got another layout, on that too, but.
Good questions.
So I mentioned network automation around here. We talked about it a couple times already, but Consul only send traffic to healthy nodes, in services. We can also use traffic shaping, splitting, those kind of things. So if I want to do a traditional blue-green, deployment, I can totally do that. I can do a canary deployment. I can say, send 10% over here, keep 90% over here. As we, validate the new service is working, we can add more traffic, those kind of things. We can do a full cutover. We'll talk about DNS query, like certain type of DNS queries called prepared queries that we can use to do that as well, and for failover and stuff.
I assume that there's on AWS, there's ways to stick an ALB on the front of this thing and stuff like that. Is that a use case for this, or is that, or you mentioned it's mostly east-west traffic? Do you typically connect with an ALB on the front end?
So Consul does have native integrations directly with some of the AWS and other cloud service mesh, service discovery services, but I don't think it would directly communicate with an ELB, because the idea is that Consul becomes the ELB.
Oh, okay.
Right, it's doing the load balancing between services that it's supporting. So you don't need an ELB in front of.
So you don't need an ALB.
Huh?
You don't need.
Yeah, you don't
ELB,
need it because Consul becomes your ELB.
Oh,
because you can do traffic shaping. By default, it's going to do round robin between the services. So I'm looking for the web service. Cool, I'm going to round robin between my 20 instances that I'm running or whatever. And then, but if you want to stand up, okay, I'm going to stand up V2. Right now we can say okay, I want 10% to go to V2 and only 90% to go to V1 kind of thing. And you can slowly fail over. You can say 50-50. You can do whatever. And that's what this is talking about, where we have service failovers, path-based routing, traffic shaping.
So
but because it becomes the load balancer, yeah, it doesn't integrate directly with other. Now it does have integrations with F5s and stuff like that as well. So if you're on-prem, you can integrate it directly with those kind of things.
I might have missed it. So when in a Kubernetes environment, does HashiCorp provide an ingress controller that it can be kind of that inbound connection to?
Yeah, I'm not the strongest on Kubernetes,
okay.
but yeah, I mean, it does provide a service where you would use to communicate with other services. Okay. So you would have to basically create your still in Kubernetes, you still register a service with it, and then I've got some examples for Kubernetes, some of the code that we use and all that kind of stuff. But
I saw Nginx on the previous slide, so maybe you just use an Nginx ingress controller and then have it route to Consul.
Yeah, I mean, you have things like the other types of gateways. They have an ingress gateway. They have those kind of things that you can use both in cloud or specifically in Kubernetes as well.
It's not just one console. Primary. You can have multiple.
Yeah, it's a cluster.
It's a
Yeah,
cluster.
yeah.
I mean, cluster of the agents, but the actual primary isn't just one node.
Oh, yeah.
Yeah. Yeah, typically, and I've got some slides on it too. This is a long deck, so like I said, there's a lot of stuff in here. But yeah, typically in a cluster, you're gonna have like three nodes or 5 nodes. Most likely like 5 nodes in a cluster for redundancy.
How big can these clusters get?
You don't want it to be much bigger than that. I think they say like really the max is about 7 because you start getting like a lot of chatter between, because you have a gossip protocol and the surf protocol, and it starts to become like really noisy when you start adding more and more nodes, because you have to, in a console cluster, you have a primary, and then you have all the others basically follower nodes. And so the primary is responsible for all the log commits and everything, and then it replicates that to all the other follower nodes, so you have the same data across all nodes. And so when you start getting really big, right, it gets really noisy.
How sensitive? It sounds like Cassandra almost. How sensitive is it to like latency?
I think they say like 10 milliseconds, 15 milliseconds between nodes. So I'm actually working with a very large bank right now. They're using Vaults with Consul on the back end, although they're having a lot of problems with the Consul back end. But they actually have Consul spread across 3 different data centers. And because they say the latency is low enough to support that, which we don't think it is, there's a lot of problems with it. But as long as you have that latency down, like you can actually have that spread across. Yeah, so thinking like a cloud environment, I always say like put it in multiple availability zones, but don't spread a Consul cluster across regions. Right.
Oh yeah. Okay.
So they kind of want to be within the same area, together, where they have high speed, low latency networking.
Gotcha.
Just within the cluster itself. You can have other clusters that are distributed, right? You can have a cluster in, one data center and another cluster in another data center, and they can communicate through peering or WAN federation. But you still have individual clusters within that node that would need to talk to each other, low latency, high throughput networking.
Gotcha.
Yeah.
Gotcha. Okay. Thanks.
This is just an example of like the failover, right? So you have a user communicating, with V1, say 100%, over to V1. We want to add V2 here. Console using like a service splitter, we can say like, okay, wait, we can put weights on here and everything like that. Again, very similar to a load balancer, right? These things that we can do with the load balancer. So you like 0 for, V1, 100% V2, and, move traffic easily, right? So we can do all those things. Again, it kind of becomes the load balancer.
That is like, so is that its own like little markup language? That doesn't look like HCL to me.
Yeah, it is HCL.
Really?
Well, yeah, this one is HCL. So they use HCL, but the funny thing is there's a couple things in Consul that still don't support HCL. They only support JSON.
Oh, okay.
Yeah, it's kind of annoying, but yeah, for the most part, almost everything, including like the configuration file, like for Consul, like this is a service splitter service, but like a service registration, all those kind of things, they all support HCL. Yeah. And then metrics. I mentioned, Envoy is not just like moving traffic. You'd actually get like layer 7 metrics, based upon your app. It can do a lot of different stuff, and so you can output those to things like Grafana. You can actually, with newer versions of Consul, you can actually output that into Grafana and then pull those into the Consul UI. So within the Consul UI, you can actually click on services, and you can have like full-blown graphs like right in the UI specifically about that service and the traffic and everything around there. And it's all like layer 7. Right? Service configuration, won't spend much time on this. It's just basically KV store, right? Pretty easy. Replicated across all the nodes. Different sizes. Again, this is from a course, so it goes into pretty deep. But again, if you have training app, you got all these variables you need to store somewhere. Consul is a great place to put them, and then all these different apps, or Jenkins or whatever, can go read from these and to deploy those apps, right? So centralized store there to deploy.
Sounds almost like etcd and.
It is. It's almost exactly like etcd. Yeah. I mean, it's the same concept. Yeah.
How would you rate Consul's KV to like Redis? It's not that.
It's not going to be that performance or anything like that. Yeah.
How performant is that?
It does. I mean, there are, if you go back, it does have things around, object size and those kind of things. I think this is actually much bigger now, only because I know we just, at the bank I'm working at, we just made it bigger than that. But yeah, so, and it does have a directory structure, although it's not really like folders. It's really just using slashes for the key, for the key there, but you can kind of organize it like that. But
yeah, it's a big value in a key value pair.
Yeah, it is.
512.
Yeah, yes, it is.
So there's no, Redis was a good question. So there's no way to extend like the key value pair into a Redis?
It doesn't have any like native ability to like replicate into it or anything like that. You'd have to probably like use API or anything like that to do that. Yeah.
It's more like you said, that's the
Yeah.
counterpart.
Yeah.
Yeah.
Yeah. Gotcha.
What else? Console basics. So again, a lot of the stuff we talked about, right? Console agent is the binary you download, right? Very similar to HashiCorp, like Vault and things like that. The same agent runs server and the client, just different configuration. You can also run dev mode like any other HashiCorp tool, right? Console agent -dev, boom, you got a local console cluster, a one node cluster running on your local machine, right? Pretty easy. And runs on all those, supports all those different operating systems and all that. Agent mode are different agent modes, right? You got server, so otherwise server O node, server agent, console node, whatever. It's basically your servers, right, that make up your console cluster. And you have your agent that runs alongside of your apps, right, as a sidecar.
I missed it. Does it run on Windows?
It does. Yeah.
Oh, really? Wow.
Ta-da. Yeah, it does.
Yay.
It's order of preference there. No, just kidding. No, I ran Windows for a long time. I think this is actually my first Mac, and I got it like 3 years ago. So I've run Windows like my entire career. So I will not bash. I will not be a Windows basher because I ran it almost my entire career. Yeah, that's true. That's very true.
Not recommended. There's WSL. Right?
Server mode versus client mode. Again, there's just really different responsibilities within the cluster, right? This is dev, right? We know dev, only used for testing, is not secure, play around on their laptop, blah, 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 right? When it comes to like actually running an organization, servers and clients, they have different responsibilities, right? Servers are responsible for things like, maintaining the state, membership, responding to queries like client queries, things like that, registering services. They maintain a quorum. So if you're familiar with Vault, using like the integrated storage, right? So we don't use console anymore, we use integrated storage to replicate between nodes. It's basically using the exact same, it is using the same exact protocol to do that, which is Raft. And then agents, their primary services are register a local service, right? So if this is an app server, right, and the agent, the idea is like this uses the agent to register a service, and it ultimately goes into the service catalog, on the server side, right? It also performs health checks and all those kind of things, and forwards, stuff to servers.
So to maintain quorum, what you just need a majority.
I'll show you.
Okay. Sorry. I'm all excited.
It's on here, yeah. Yeah. Single data center. So a data center, console has a concept of what's called a data center, right? This is a data center, right? It's made up of both servers and clients, is a data center. Typically, a data center doesn't really span outside four walls of a region or a physical data center or something like that. Again, low latency, high throughput network between your servers itself, most importantly, but also between your agents. So ideally, if you're thinking cloud, like US East, or something like that here, or another one would be US West or whatever, right? And I think there's maybe another one that has on here. Yeah, I just said all this. What is a data center? Single cluster, private low latency, blah, blah, blah. What a data center is not, multi-region, multiple clusters, using the WAN gossip protocol, communicates across the WAN or internet, right? It's all local for a single data center. And they do spell data center without the space there. Every time I type it in. And so then you can have multiple data centers, right? So again, each individual data center, you've got a cluster here, you got a cluster there, you got clients here, you got clients over there, right? They communicate with the local server for clients there. But then you can have these peered, and I've got a couple slides, you have these federation or peered between, so they can actually, this service, as I showed before, if this service is dead, it can actually communicate with this service over here if he needs to through federation or through peering. Or I mentioned the sameness groups before. Multi-data center, pretty obvious, right? Or just kind of thing. So this is WAN federation. So the two different ways you communicate multiple clusters together. WAN federation used to be the only way that you can do that, right? So again, you have two data centers. Again, this comes from my from that Kubernetes example. So this is what we had deployed, US East 1 and 2, all running on EKS 3-node cluster. I think we ended up scaling up to 6 nodes on each one. And then what happens is you actually have to have communication between these data centers for like a network, right? Because you have You're always going to have a primary data center. You're going to have secondary data center or data centers, right? But you're always going to have a primary data center. And this data center is responsible for maintaining a lot of this stuff. Like each one has services, each one has intentions, but there's one that's primary for like ACLs and TLS and things like that. That's going to replicate from one to the other. So you have the community. So you have to have this physical, this actual networking community connection between, and then each data center is going to have its own services, right? So again, this is for our RPT hotel app that we have. So we had it deploy. You see hotel app front end 1 and front end 2, and then our back end, and we have just the back end and another app over here. And console injector is basically using the Helm chart. You can enable the console injector, and that's basically injecting the agent inside that pod, right? So it's called the injector. Vault has an injector as well. So whenever I deploy an application using Kubernetes, using a Helm chart, using whatever, the console injector will look for that and throw in that sidecar basically, and be able to handle that communication. Now you can enable service mesh and those kind of things through that. The other way is data center peering. Similar but different. Still have a dedicated cluster to each data center, your own apps running in each data center, but now you don't actually need that physical connectivity anymore because we're not actually replicating things from here to here, but typically we're going to have mesh gateways, and these may be internet facing here, and this is exactly what we did. These lived on the internet, and then we had these communicating across the internet from like US East 1 to US East 2. So you can still have this failover. You can create sameness, what's called sameness groups, so you can have like this backend V1 and backend V1, you can put those in what's called sameness groups, and then it's kind of funky, but you have to like export, you create the sameness group, and then you have to like export services from here into there, and export service from there into here, so they kind of know about each other. But then you have that failover capability, right? So if you have the front end trying to communicate the back end, and then we kill that back end, it knows exactly where this back end is, and it can communicate with that back end across the mesh gateway, so now it is in the data path, and then communicate with this back end without this front end communicating directly to this back end. Now the gateways are actually in the data path and enabling that communication between clusters. So pretty cool. This is just a slide showing both, right? WAN federation, down here you have replication from your primary into the others, peer data centers. The idea behind peer data centers is more like you can become more like more hub and spoke-ish, right? So you can have multiple things. So you can have data center A can be paired with B, B can be paired with C, but A and C can't talk, kind of thing, right? So you can kind of peer different things together as you need. So it's one or the other. You wouldn't do both. But today, like this is really like old news. This is WAN federation. It's kind of going away in favor of peering. So peering is kind of like what you would do today. When we were doing that whole demo stuff, I spent all the time, because I knew how to do WAN federation. It's harder to do. Not that this is easy, but it's a little harder to do. But I had everything set up, and then we're like, oh, we're presenting to Hashi. We should do like the new peering stuff. And so we like tore everything down and then redid everything with peering. So it is a little confusing. It's just new things to learn. Okay, I got to do a sameness group. I got export services. I got to do those kind of things. I feel like it's a little bit less automated because once you get peering and stuff done, then services over here, they kind of automatically know about each other just by the data center name. So you could actually say purposely, you could say I want a service over here to communicate with this service. And all you have to do is add, when you're making a DNS query, all you have to do is add the other data center name in that DNS query, and boom, it's going to hit this service instead of that service, right? So it's a little bit different, but peering is basically the way to go today. Protocols, I mentioned Surf Protocol, Consensus Protocol, Raft. I mentioned Vault before, integrated storage. When you configure it, you actually call out, it specifically says Raft right in there. That's the protocol that it's going to use. Raft and Consul is only used between servers for consensus, leadership elections, all that kind of stuff. Gossip is actually pretty cool. Gossip runs across everything, and Gossip is exactly what it sounds like. It's everybody talking to everybody, right? From a client perspective, this client were to go down, and Consul says, oh, you know what, I can't see this client anymore. Consul may actually reach out to this and say, hey, can you see this client? And it's like, no, this guy would say, no, this client's down too. I see he's down. He'd say, okay, he must be down. We can't see him. Other clients can't see him. So it kind of enables that communication across the whole infrastructure. So it's kind of neat. This is just a lot of stuff. Actually, I kind of scaled these back. Based upon Raft, like I said, the same exact protocol is actually used in Vault, and it's actually used in Nomad as well. So it uses Raft as well. Strongly consistent, used only on server nodes. Responsible for things like leadership elections, committed log entries, right? So again, you have one kind of leader within the cluster. It's responsible for committing all those logs and then replicating that to all the other followers, so they have the same data. So if one were to go down, same data exists on everything. And then establishing the quorum as well. This is more consensus, leader versus follower. Kind of mentioned that already. This is what it looks like. Release engineer wants to make a change to like KV or something like that. Just pushes it to console, right? Really hits the leader node. The leader node makes those commits, right? KV right, and then replicates that data to all the other nodes. So there you go, Raft. Gossip used cluster wide, including multiple clusters. So there's actually LAN gossip, which exists within the cluster itself. And when you use WAN federation, you have WAN gossip as well, so you communicate with other clusters. It's used by clients and servers, and it's used to manage membership of the cluster, like for everything, right? It broadcasts messages across the entire cluster. Again, there's a LAN and a WAN there as well. There's the differences, right? Each cluster has its own LAN gossip pool, but then when you enable federation, you also have a WAN gossip pool too. I think I slide on that, but high availability through a cluster. Hashi recommends 3 to 5 servers. 3 would be good for like a dev environment. 3, you can lose 1 node and still be up. You lose the second node, you're down. 5 node cluster, you can actually lose 2 nodes and still be up. You lose a third, you're down. I think it's probably the next slide. Diagram on that. Uses the consensus protocol, which is the Raft, to establish a cluster leader. Actually, I took it out, but I have a cool, kind of dumb, but slide about just how leadership election works. And all. It's all based upon like randomized timing and things like that. Basically, like whoever said, someone says, "Hey, vote for me," and they've got the lowest like millisecond timeout or whatever. The first person says, "Hey, vote on me," and everyone else is like, "Cool, no one else is voting. Like, we'll vote for you," or whatever. It's kind of neat how it all works, but. I took it out because I thought it was too much for this one. But general recommendation not to exceed, cause a lot of replication. You saw all the go back. All the for traffic replication. Again, that leader node's got to replicate all that data to all the other nodes. Plus, more than 7 servers could impact the network, right? Because now you have the gossip protocol also happening on the back end between all the servers and clients as well. So. Fault tolerance, this is where that quorum size is, where you asked about the quorum. So depending on the number of server nodes that we put inside of our cluster, what is our failure tolerance and what is our quorum, right? We have to maintain a quorum in order to keep the console service up and running. And based upon the number of nodes, this is how many servers we can lose in order for console to remain up and running, right? So 1 and 2, like you don't have any failure tolerance. You have failure tolerance when you hit 3 server nodes, so that's where you'd run something like dev. I think I got some call-outs and say only for testing, don't do that. Minimal but acceptable, right? So the dev environments, whatever. Maybe if you're adding like a read replica or something there, I don't know why you'd add 4. It's almost always, you're going to always have an odd number. There is a little exception in here for 6, and that's if you're using what's called redundancy zones. And so I have clients using this right now. Redundancy zones is really like you have 6 nodes. Each node may live in like a fault zone, right? So think of a data center like I've got 2 nodes in this rack, 2 nodes in this rack, 2 nodes in this rack. In a cloud, I got 2 nodes in this AZ, 2 in this AZ, 2 in this AZ. But the nodes know what AZ they're in, not like officially, like I'm in AWS US East 1. You tell like you're in AZ 1, you're in AZ 2, and what happens is when you have 6. You typically will put 2 in each zone, And then what happens is Consul will automatically make 3 of those a voting member and 3 of those a non-voting member. And I don't know if I have slides on this one before. I know I have them. I just don't know if they're in here. But basically what happens is you have 3 voting members. So you're down to being able to lose 1 node, right? Like we talked about right here. But if one of those voting members goes down, one of the non-voting members immediately gets promoted to a voting member to replace it. So now you still have 3. You lose another one, so it gets replaced, right? So when you have 6, you can actually lose up to 4 nodes and still be up and running, because now that means like if you lose them like one at a time. If you lose like a bunch of them at the same time, it may not work out great for you, right? But if you do lose them one at a time, then you can actually lose 4, because if you think about it, I've got 3 voting members. I lose 1, another voting member. I'm down to 5, but another non-voting member gets promoted. I'm back to 3, right, with 2 left. 1 dies, gets promoted, gets promoted, gets promoted. Like we have this continuation of non-voters getting promoted until we're down to two voting members, and that essentially really gets us to the point where we're right here. Eventually, when we have still 3, we lose that 4th server, which is right here. We have 2 left. We're still up and running. We lose 1 more, then we're down. So it's kind of a fancy way to get this times 2, kind of. It kind of automates all that on the back end. It's really cool because I set this up for the bank I'm working with right now. They were not using redundancy zones, although they had 6 deployed. So they had 5 nodes, which were voting members, and they purposely added another node, which really didn't do anything for them. And specifically in the configuration file, it said your non-voting server. So again, it really wasn't doing anything for them. And so because we already had 2, 2, and 2, they had 2 nodes in this data center, 2 here, 2 here. I reconfigured everything to use redundancy zones, and it's really cool to see like when you just do like a vault. Use vault so much. I'm talking about vault. Console operator Raffless peers, and just like run it over and over and over and over. After you enable this, you can actually see like console like moving things around. Like, oh, there's now I need a voting member here. I need a voting member over here. You can see nodes become non-voters and voters, like as it moves things around for you. It's like, okay, now I've got 1 voting member and 1 non-voting member here, 1 here, same thing. So it's kind of neat to see that happen in real time. And then, wonderful idea. You can lose up to 3 nodes in a cluster here and still be up and running, right? So I like here, this is usually what I do for Vault as well. Vault follows the exact same stuff if you're using Raft, like integrated storage. I'm always go 5 nodes because it gives you the ability to take down a node for maintenance, and you still can lose 1 during that process and still be up and running, right? So it really kind of gives you like this N+2 architecture, and so it gives you a little bit of safe space in the event that you lose a node while you're doing maintenance. You still are up and running, right? Scaling for performance. I mentioned read replicas or read scalability before. You can actually create non-voting members in the cluster so they don't take part in leadership elections. So that last chart I just showed you, like they wouldn't participate for that, but they still receive all the data. And so you can actually create, I think I have a thing on here. You can actually create other read replicas in here. They still receive all the data from the primary nodes, but you can actually send traffic here for just reads now, right? So it's a way you can scale out console without impacting what the quorum is. So when you said how many nodes, you can actually scale this out very large, and it doesn't necessarily impact like your consensus protocol and the quorum and all that kind of stuff, because these remain voting members, these are non-voting members. I don't know what the arrow's for. Service. So we talked a lot about stuff. What is the service, right? Any kind of workload, running in your infrastructure here. Service catalog. They all get registered. You obviously perform a DNS query. As I mentioned, clients. You think about what's going to query these. It could be an end user. It could be people on a call floor. It could be people that are remote, right? If you're using DNS, right? Ultimately, these DNS queries need to end up here to hit that service catalog, right? And so typically what's going to happen is you're going to use, by default, Consul will use a .consul domain. And so you can change that if you wanted to. But if you're trying to find like the inventory service, it may be inventory.service.consul. That's the actual DNS query. That's the name we're going to ask for, right? And so if this user is at home or on a call floor or whatever, their machine may be querying like your traditional DNS servers that you're already using in your environment. And again, I mentioned a lot of times you'll create like forwarders or something like that to say, hey, if you're looking for a .console DNS name, forward that to my console clusters, right? And console is running DNS, right? Or it's listening for DNS. By default, it listens on port 8600. If you want it to listen on 53, you can do that, but most people will install like bind or something like that and then just redirect it, right? If I'm going to 53, bind will listen to 53 because you don't want console running as a root, right? Because anything under 1024 has to run as a root user, like on Linux or whatever. And so you don't want console running as a root user. So typically we would install, if you want 53, right, you would install bind on your servers. Bind is listing on 53, but all bind is doing is redirecting it to 8600 to console, right? That way you don't have to change the functionality of a console. But if this user queries for any of these .console, ultimately it's going to get to your DNS servers. You say DNS servers forward all that stuff to my console. Console's like, cool, I know what that service is. Here's the response, right? And it's going to act as the authoritative DNS server for .console and for it's going to be able to provide records for any of this stuff. And the cool thing, again, it knows what inventory, where inventory is. It also knows which ones are healthy, which ones are down, and it's only going to provide it with healthy nodes, as a response. You can also do API requests, right? So if you want to, if you don't want to use DNS, you can have apps make an actual API request to console saying, where's the inventory service, where's the identity service, whatever. It will return healthy nodes just like DNS would. This is a service. I think service may be one of those that does not yet support HCL. I may be wrong. I probably am wrong. I feel like I am wrong.
That looks like HCL.
But well, this is JSON.
Oh,
Yeah. Anytime you're opening with those the brackets,
the opening bracket,
curly braces. But this is what like a very, very basic service would look like, right? So the name of the server, or like that's running the service, right? So you're spinning up VMs or whatever, like what's the name of that? That way in console, it knows like what the node names are that's hosting these services as well. This is the name of the service to be registered. So we talked about, we had front end, back end, search, whatever. Like this is the name that the app is going to register itself as. So again, you could have 100 different front-end e-commerce, right? And it's going to create that service catalog. And it's going to load balance between all those front-end e-commerce. But this is what the configuration file would look like. You can have optional tags in here, and we'll mention that, talk about that before, where we can use those. The address, right? I think by default it would grab that anyway, so you don't have to necessarily. But if you have multiple interfaces, like what interface do we want to use for this service? What port is the service listening on? Pretty important. And then we have health checks in there. We mentioned that the agent itself can perform health checks for the service. So in this case, it can run. This is running a script, like check the memory, of the service. What, Mark?
I have to ask an Azure question. Can you use GUIDs for the ID? Any Azure users?
Yeah, you should be able to. I don't see why not. Yeah.
Azure uses GUIDs for everything. Yeah. It's the most sophisticated GUID generator on the planet. Just.
Yeah, I don't know why you couldn't. Yep. But this is what a very basic config might look like here. Multiple nodes provide, so multiple nodes, obviously deploying multiple instances of the same app provides high availability. Again, only registered services passing those health checks, right, will be returned to a user requesting that service. So again, build that out real quick. Console cluster over here, search, right? 6 instances of the search service, right? Again, I mentioned you have node level checks, and you can have service level checks. So the node level may say like, is the CPU okay? Is the disk okay? Is it blah blah blah? If it is, then if this search 5 was hosting other apps as well, all those apps will be marked as unhealthy if the node itself is unhealthy. But if the node is okay and like the service is just down, then just this service. But if this node itself, say if this was like a VM or something, is also hosting 5 other, then those other may still be healthy because only the service is down, not necessarily the node. So you have 2 different types of checks. And of course you got, in this example, I've got 2 that are down. So over here, I got 6 services of this, 6 instances of the search service that are registered, but 2 of them are unhealthy. So if I make that API request or DNS request, it's only going to return one of these four, load balance between one of those four, right? It's never going to send a response for an unhealthy node there. Service health checks, sorry. Yeah, it can be critical, passing, added a service, right? Different types of health checks. It supports a lot of different types of health checks, right? You can have just run a script. You saw the Python script before where it's doing something, returning something back. HTTP health check, are we getting a 200 back from the service? Is a port open? Is it available? TTL, right? Docker health check. There's probably other health checks in here as well now, but I like this one, the alias health check. If you have services that are dependent on other services, right? So if you have like say a 3-tier service, and the say for some reason like they're communicating like, okay, node 1 talks to each other, node 2 talks to each other, across the board. If somewhere along that line, like the web service is healthy, but maybe the backend app is not, like it won't pass. That the web won't pass, and we won't provide that back to the user because we know that the second tier is down, right? So it won't. So the health check is say like, okay, is my backend service also healthy? If it's not, then I won't give that to the user, because even though the web service may be broken, I know that a service that I'm relying on is broken, and the user won't have a good experience, right? Because something in that path is broken. So you can actually do that as well. So if you think about like, is DynamoDB available? Is your other types of services that we're relying on, are they available? If so, then it doesn't pass the health check. Yeah.
So I know this is sort of going way back, but you gave the example just at the service discovery of like Mongo kind of going, and then that one goes away, and then it goes to the other one.
Yep.
And everything's good. I kind of thought like, if that was a blip or something, if it came back, the original one that went out,
Yep.
you really want Consul to like, well, the health check is saying it's back online. I'm going to start routing traffic
Yep.
there when this is now the primary.
Right.
And I know that would be sort of Mongo's responsibility to sort of know whether you're primary, secondary, and if you've gone primary, you don't bring secondary up. But I just thought it would seem like the Consul checks would have to be a little bit more sophisticated to know whether that Mongo instance that went away is really back, or just it's alive, but its database is out of sync. Or is that really the responsibility of the database?
Yeah, I mean, there's both. I mean, you'd have to have like a proper check on there to say like, is the database, it's not only just enough to say like, is 3306 available, but you can also put a script on there. Can I read from a table, or something like that? You could do that. But I think what you mentioned before is like, let's see if I have, like this, from a DNS perspective, like this was an API, but if you're making a DNS request, like these DNS queries are basically like have a TTL of 0, right? So we're not caching those DNS queries. So as soon as that database, I'm not gonna go all the way back, but as soon as that database service will come back online, passing health checks, because we're not caching that DNS response of like which one is available, the next time it needs it, it's going to query Consul again and say like, oh, this one's healthy again, and fail back to the local instance and not continue to communicate with the remote instance. Yeah. Yeah. And then of course, same thing with the API, right? We're going to not cache that response. We're going to say like, every time you need to talk to Mongo, you're like, make an API request to figure out where it is, right? Because these could be containers that are coming up and down and those kind of things, right? So that could be scaling up and down and stuff like that. So we obviously, need to do the health checks and provide, the health back to the service catalog. So we're always returning healthy nodes, and that's regardless if we're doing API or DNS. So, but from a DNS perspective, like those records would have like a TTL of 0, so we're not caching that response. Talk about health checks. So just 2 examples. You saw that Python right here. So you run a Python limit, right? And is it under this, under this usage? If it is, cool. If it's above it, bad, right? Health check, right? We're actually maybe hitting an actual health endpoint here. right? And seeing, and if we have intervals and timeouts and all that kind of stuff. Very similar to like what you see on like a load balancer, right? Making sure that the service is healthy. DNS queries, we just talked about this. So again, console at this point, like again, really talking about service discovery, not in the data path here, right? And that's why I specifically drew it like that, because we make all these calls, Java app still talks directly to the database, right? It doesn't go through console. Here is checking the status, using DNS, so just using a dig command. So we're gonna dig, like this is the console server, port 8600 as I mentioned. We're gonna look for this specific service, so front-end ecommerce.service.console, right? And we get the service back, the A record back from console. So the one node that's healthy there. But API requests, again, very similar. Curl API endpoint, so catalog service and then the name of the service here. And again, we get the nodes, number of nodes that are passing, and then the address of the node that we should connect to. This is an older screenshot, but still very similar. Inside the UI, you can see the list of services in there. You can see the tags. I mentioned tags before. You can see them listed in there. You can see the healthy database service. It would have an X on there if it was not healthy. And then if you go in there, you can actually see the nodes, like the instances of this, right? So if we have front-end commerce and it's made up of 20 instances, right? We'd have all those different instances laid out. But we still only have one service, even though it's being hosted by a bunch of different instances out here, right? So you would see like the IP address and all. I think I was running all this on my laptop, so it's 127, but you would see the IP address and all that kind of stuff across here. This is on the Kubernetes side. It talks a lot about the service catalog, right? One of the things that Consul, I guess HashiCorp is trying to do is when you're running Consul on Kubernetes, Kubernetes already provides, I would say, some of the services that Consul does, right? It provides a service catalog. It provides DNS and those kind of things, right? So what they're starting to do is starting to integrate those. So this example up here is of a CRD. This is from our when you run like a Helm chart, you usually have like a values.yaml to make your own configurations. So up here you can see like we have a catalog sync. So we're actually syncing the Kubernetes catalog to Consul, and you can go bidirectional. So as you're registering services inside of Kubernetes, so you're launching new containers and those kind of things, it will automatically populate Consul service catalog based upon containers that are launched inside of Kubernetes. And so they don't actually you don't have to have apps that are launched in Kubernetes actually register themselves with Consul. That catalog sync will do it for you. So now you can have services go query for other services without having to interact directly with Consul itself. And this is how you do it. This is from the Helm chart. And a couple things, like you have like default, we were using Argo, so deny namespaces basically just shows like don't sync those into, so I don't see them in Consul, right? So don't sync these, but sync everything else. And again, you can see like enable true and then to Kubernetes. So if I register stuff in Consul, should I sync it back to Kubernetes? You may want to, you may not. In this case, I didn't. I only did a one-way sync from Kubernetes into Consul. So kind of cool there. Traffic shaping, we talked about this before, right? Setting a certain amount of traffic from front end v1, front end v2, right? And it can all be based upon tags. This one, because it's Kubernetes, when you register it, you tell it which subset it is. So 50%, here you register these subsets of v1, v2, or whatever you want to, it's just an open string. You can call it whatever you want.
Go back to the slide.
Yeah.
Can you give an example where you would have the two Kubernetes be true? Like, and what kind of data would be coming from Consul that you would want to put back in your Kubernetes cluster?
Yeah, I mean, I guess maybe if you have, if you have some apps that are running in Kubernetes and you have some apps that are still running on like traditional VMs and those kind of things, right, that are registering with Consul, then you would want Consul to maybe send those over to Kubernetes, and you can actually have services query the service catalog in Kubernetes instead of going to Consul to get those services.
And
Yeah.
Kubernetes would talk to those legacy.
Yeah, exactly. Yeah, so you have services register here, you can sync those back, and then because you can have, because you have this sync, you can actually have services, just query the local catalog because they're the same, right? I mean, so you can do that instead of having to have those services go back to Consul. Yeah. That was fun, but a pain in the butt to set up, but it was good a good exercise there. I don't know how much time we have left. This is from an 8-hour course, so I got 8 hours of material. Not in this slide. It is. A lot of this stuff is from an eight and a half hour
I'm getting
course.
my money's worth.
Yeah.
Dang.
So I mentioned like DNS. DNS is one of the ways you can find healthy services. Well, you can do these custom DNS queries, and it's called a prepare query. So now it allows you to create and register like more complex service queries that you can execute from an app. So I showed the example before. If I'm looking for search, the search service, right? I would query for search.service.console, right? But in this case, maybe I want to get a little bit more creative. I only want version 2 of the search service, or I only want production or something like that. I can actually go into Console and create these custom prepared queries, and I get a specific DNS name out of that, where you have like service.query.console instead. And so now you can add additional logic to see like what should be returned versus just like what's healthy. Okay, I got 10 that are healthy, but maybe I only want version 2, which is 4 servers I just launched. Maybe I only want traffic to go there instead, right? So you can use what's called a prepared query to do that. So yeah, instead of something that's service, you have the name.query.console, and that's what your app would query for the DNS instead of just service. And I'll show you an example of it. So I need to connect to a service. Cool. Got all these services out here running, right? Got some that, some are healthy, some are not, some are different versions, blah, 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 all right? So, all right, my service, it's got to be healthy. All right, cool. We don't worry about that one, right? It must be the web app, right? Kind of narrows it down. And it must have a tag of, maybe the newer version, 6.4. That's and this could be like, 100 instances or whatever, right? They all register themselves with the same tags and stuff. So you can create a prepare query that gives you that exact result, right? So then it goes away, boom, we're down to this one. What does that look like? The name, that's just the name of the prepare query. The service that we're targeting, right? We're targeting that web app service, not the database service, and the web app service. What are the tags that I need? I'm looking specifically for this version. By the way, we can also have failover as well. And so if I don't find, it's always gonna look in the local data center first, and then it will fail to DC2 and DC3. So if if this doesn't meet any services in data center 1, in DC1, it'll look for DC2, it'll look for DC3, and find those services that exist. So this is another way we can use prepare queries to provide failover services between data centers as well. So again, name of the prepared query, failover policy. This is a static failover policy, and so it goes in order, right? So it'll find that it'll search for the local DC first, DC1, right? Then it'll go to DC2, then it will go to DC3 in that specific order. There are other, I don't know if I included them in here. I think I skipped them, but there are other, there's like a hybrid, and then there's like a dynamic failover policy as well. You can have other stuff in there. You can have it based upon like latency and things like that too. Service mesh, this is where I had some other slides in here. We kind of talked about it, but I want to mention like the primary components of the service mesh. So again, service discovery, key. We have the CA, that could be console, could be vault, could be whatever. You get your services that are registered, sidecar proxy. Your upstream configuration, that means like I'm a web service, my upstream service is going to be like a database or something I need to talk to. MTLS certs, and then your intentions, basically kind of like your rules in there. And this is just a very similar architecture around, what it looks like. So sidecar proxy, MTLS certs across the board, encrypted communication, your intentions down here. to allow services. You can't see because of the screen, but these are allowed, but this one's deny, right? So whatever that service is. The workflow here, so how does it work? So the source requests a connection, so it needs to communicate with the upstream service. It validates the upstream service cert against the cert bundle, so that's with our authentication, right, for our MTLS. So then it validates here. Intention check, so it checks console using like the API to check to make sure that service is permitted to talk to that service, and then the connection is established between the proxies there. Intentions, basically use the service graph, again, very similar to like a firewall. You can have default, you see a policy, default allow, default deny. Service graph, right, so allow those communications, yeah, those can talk, but inventory, those may not be able to talk, right? And again, scaling out, the important thing is we only need one rule, and we can scale out these individually. We don't need to change these. This is just what the graph for the order there. This is, see. Oh, so this is, sorry, this is kind of a Frankenstein deck a little bit. So I apologize for jumping around a little bit. We're going back, I was talking about availability or redundancy zones where you have 2, 2, and 2. This is what it looks like in Kubernetes. Basically, you have your servers, you have affinity in here, you have your extra config, and you're adding node meta in here, and you're saying what zone, and we're basically doing it by host IP, right? And so because we have affinity, pod infinity here, basically we're telling it to run servers, run pods on different nodes, then we can actually set it up where we have like 2, 2, and 2, across the board. So you can see here, we have non-voters across the board, follower and leader. These are the ones that are voting members up here. These are non-voters down there. So you can kind of use Kubernetes configuration like infinities to push those across like different hosts, and then you can have the host IP like set used for metadata that because you can use anything for I can call this Bryan and you can use whatever value you want there, right? It's just a KV right here, but that's just the way you can kind of integrate the two and still use redundancy zones there. This is the this is service mesh. Let me see, sorry. Yeah, so this is the injector I was talking about here. So when you deploy like your front end app, you can actually say, I want to inject anytime you see connect, that's like the old school name of service, what HashiCorp calls service mesh now. It used to be called Consul Connect. And so that name still exists in a couple places. Anytime you see connect, it's actually just talking about the service mesh where we're talking about TLS certs between proxies and all that kind of stuff. That's what they used to call connect. So connect injector true, so it's going to inject it's the console agent into the pod here. And you actually see in the UI here, when we register the counting service, it actually specifically says it knows that it's in the service mesh using a proxy. So it'll show you that in the UI. And then up here too, this is the same thing, the value, so deploying the console cluster as well. You can actually see, we're gonna use the transparent proxy, but we're also, right here, enabled by default, we're going to inject. You can inject everything, don't inject for everything, these are my notes. Use annotations on the app instead, right? So if you put this to true, it would inject that proxy in every app you deploy in Kubernetes. If you set that default, you have to add this into each individual app, right? So you may have apps that you want and some you don't, right? So you set this default, you just add default to false, and you just add this inside of your YAML for your individual pods, and workloads that you're running in here. So that's what, and all these others are, I'm gonna add service tags. Right, so those are, you can see some of the tags right here, like backend, right here, the tag, V1. I'm going to enable metrics, those I was talking about, where you can send metrics into like Grafana and those kind of things and ultimately see it in the UI. And then you got service accounts and stuff like that. But and that's apparently all of them. But Any questions on?
Wow.
Kind of quick ending. Yeah. Any other questions? I know I went through a lot of stuff there in almost 2 hours.
Let me check online.
Yeah. Again, the service discovery piece is kind of like you can kind of see all the other stuff kind of depends on the service discovery, the catalog. And now with like newer versions, we've got, we're pulling in a lot of the feature sets, from Kubernetes and stuff like that because we don't need a repeat. A lot of stuff that Kubernetes is already doing. So kind of taking advantage of the stuff that's already there.
How much is console, I don't say dependent, but integrated with Vault? Like, is they much hand in hand, but you can do it on your own with console, but it's just like becomes hard, and you just run into obstacles.
So you're talking about from a Vault perspective or a console perspective?
From a
console.
perspective,
So yeah, you don't need Vault at all if you don't want Vault. Right. But there are some good integrations between the two. As I mentioned, when you're using like Service Mesh, you can use Vault, the PKI secrets engine in Vault to automatically provision and create all your MTLS certs across the board. So you can do that. You can also, Vault has console secret engine and also has, I don't know if it has the workload identity stuff yet, but you have the console secrets engine. So you can have Vault dynamically generate console ACL tokens as well. So if you have, an app that needs to communicate with console or register a service, you actually have it grab a token from Vault first and then use that token to communicate with console to register a service or make changes or something like that. I'm actually working with an education company right now that they're full-blown like HashiStack, right? That they're running all their workloads on Nomad, and what they want is they also have console and they also have Vault, and they want, because you have to have like OIDC and stuff like that as an enterprise feature of they want to integrate that with like their Azure AD and things like that, but they don't want to pay for enterprise, which is totally cool. But so what we're doing is when they want to have admins or developers access like Nomad or console, they're gonna have them log into Vault using OIDC because it's free, right? You can connect that into like Azure AD or LDAP or whatever, and then through Vault they're gonna obtain a console token or a Nomad token in order to access the platform, right? So they still force them through using OIDC, but through Vault. And the cool thing with that is then we can dynamically generate that token, and we can put a very short TTL on that as well, right? So we don't have to create like a long-lived admin token for console, and then it gets lost and gets compromised or whatever. We put a TTL behind it that says that token's only valid for 4 hours or 8 hours, and then it expires automatically. And they do the same thing the next time they need console or Nomad or whatever.
Are there other integrations with other CAs like,
Venafi, they integrate with that. They integrate with like Microsoft CA, like pretty much any kind of CA it has support to integrate.
I don't know why I couldn't think of it.
Oh yeah. The free.
Yeah, I don't know if.
TLS.
Yeah. I don't know if Let's Encrypt, because most of the time like the TLS certs that we're talking about are all like internal certs. They're not publicly facing certs. So I don't know if Let's Encrypt is on there or not. It might be, but most of the time we're talking like an internal PKI solution that's already running within your org.
That's what we're looking for anyway. This is all I think.
Yeah,
So
yeah,
you don't even need to combine it.
exactly, yeah. So to clear up a little bit for console, it can be complex, especially like when you all that peering stuff. It's when we started doing it last year, it was a lot of stuff is actually some of it's still in beta. So honestly, sometimes it's kind of hard to find experts inside of Hashi that are strong. Like I have actually one of the guys I talk to a lot. He's just in Dayton, super incredibly strong on console. He's one of my go-tos. I've got a couple of people that are like promoted to managers, but they're still pretty strong on it as well. But I've got key people because I'm on HashiCorp's corporate Slack, so I can just like ping people. I'm like, hey, have you seen this, or how do I do this? And they're like, yeah, that's not fun to do. Let me send you an example. And especially the new peering stuff, it's kind of complex. But I mean, it works great once it's set up. But yeah, so
Amazing.
cool. Yeah, thank you all for having me. I appreciate it.
Thank
hopefully it was all right.
Bryan Krausen, man. That's
Yeah.
amazing. Thank you so much. You brought some.
Yeah, I
some
brought some
swag
books. Yeah.
of your own.
So I brought a couple of books. I've published 2 books on Vault. One I co-wrote with Dan McTeer, who kind of leads the RSA organization, which is like the resident solutions architect at Hashi. So him and I did that like 2 years ago. This one I published last year, and actually I didn't write the majority of this one. Because I've been working with Vault for 7 or 8 years. I know everyone in the community who's good at Vault, who's not good at Vault. And so I worked with everyone I know who's really good at Vault, and basically solicited like, hey, write a section, right? And the idea was like, it's all community-based, right? The idea is like, hey, give me something that's not necessarily like in the documentation. It's something that you need to have experience, working with Vault day to day to like understand and truly, grasp. And that's what that was kind of, And so I sell this. I don't keep any of the profits. I donate all, anything that's I get back from Amazon. I just donate that because it's a community project. So there's like maybe 20 different authors that wrote. Some of them wrote a lot more than others. Some of them like, hey, here's my 30-page. I'm like, oh my gosh, this is gonna be a book on its own. Others were, short and sweet, but a lot of good material. And it's broken down into like, design, security, like policies. Day 2 operations, integration with apps, so like Nomad, Kubernetes, all those kind of things are all kind of grouped together. So it's kind of grouped together like that. And I had, my buddy Armand wrote the wrote the foreword for this one as well.
Nice.
So
I got mine signed, and you can too.
Yeah, happy to do it.
Right?
Oh, you brought one. Awesome.
I got
Brian McDonald's. Okay. Okay. Yeah, Brian's
There
a
we go,
coworker.
there we
Brian's a
go.
coworker of mine. He's actually on the same projects I'm working on now. He just got added to the bank.
Didn't I meet him at HashiCorp?
Yeah, he's got a big long
Yeah.
red beard. Yeah, that's Brian.
I think he signed my copy too.
Yeah. Yeah.
So,
So we had there's actually quite a bunch of the authors were at HashiConf. So they're like, hey, sign my book. I'm like, Brian wrote it. So I was trying to send them to everybody else. Like, they wrote all these too.
Ned was there. Ned's on.
Yeah.
You guys know Ned? Ned Belvins?
Ned in the cloud.
Ned in the cloud. Yeah, he's on here. Yeah, it's a really cool idea.
Yeah, I'm gonna
It's
do the
really
same
cool.
thing for Terraform. Actually, when I started
Uh-oh.
that, yeah, when I started that, I actually have like a list of like 25 people who were gonna write for Terraform. But
there's so
honestly, a lot of it was on me that I didn't, I followed up with some, I didn't push them hard enough to write. It was pain to get these 20 people to to get there.
Talk about hurting cats.
Yeah, and then it's a lot of work on my side because then I had to like format it. Some people gave it to me in the Google Doc, some gave it to me in Markdown, some gave it to me in Word, and so then I had to put it all together, format it all the same so it read consistently throughout the book. And I didn't change the words, but the formatting and stuff was a pain to go through all that. So it was not a little bit of work on my side, but I didn't write it, but it was a lot of work still. So.
That's super cool.
But yeah.
Should we count these off? If you want one, just raise your hand and we'll count off. And I'll
I
do
only
the
brought
random
3
number-
with me, so.
Random number generator. Or how do you? So who wants one of these books? Raise your hand. Oh, okay. There we go. Oh, well, we got enough then. Okay, there we go. So here you go. Cool. Yep. Pass these out.
And I keep that, I manage that on Amazon, and I keep it pretty much as cheap as Amazon will let me keep it. So the idea wasn't to make a profit. It was just like to get this community information out to the community. So that was really what it was all about. I did I have secretsofvault.com, so this is kind of like a promotion for that book. I also have Secrets of Terraform, I think.
Ooh.
Best kept secrets, something like that.
Exciting.
But the idea was I was going to go all out. I was going to do one on like Nomad. I was going to do one on Kubernetes, AWS, because I know I've been in the community for a long time, and I know like a lot of key players and like a lot of these different technologies. And so I bought all these domains, and the idea was like it's going to create a similar book for bunch of different technologies. But
Yeah. I think it's a good idea.
I got like a million projects.
Man never sleeps.
Yeah, I don't feel
So
like it.
I got a couple mugs here. This one says it's got my favorite, thing that I type in. It's called Terraform Apply Auto Approve. So, anybody want this one? You want it? Okay, we got a taker. There we go.
So at HashiConf last year, it was the year before, Riverpoint, we made up stickers, funny stickers that says like TF YOLO equals It was basically creating the alias for auto approve, like TF YOLO. So we gave those stickers away. I think we gave away some last year too. We had some left over, but
YOLO, baby. And then last one, this is my customized Terraform logo for Azure Terraformers. I don't know if we got an Azure crowd in here though, but it's still the Terraform logo. You want it? You want it? No? Yeah, okay. You gotta twist some arms here, man. Here you go. Here you go.
I already got an idea for your Terraform TF switch.
TF switch. I don't know.
I've never heard it.
It lets you, from the command line, you can pick
Different versions. Yeah. Okay. Yeah.
Oh.
versions.
Yeah.
This version of Terraform.
Yeah.
You can just use it and apply it like you're just on.
We use like TF test a lot, which is a similar thing. We TF test against specific versions and stuff like that. Yeah. Yeah. Yeah.
Cool. Well, thank you, Brian.
Cool.
Again.
Yeah, thank you all
Thank you
very
guys
much.
for coming. Check out the Sessionize link. You guys, hopefully, you guys have seen that. We need a speaker for May. So, anybody interested in giving a talk on anything HashiCorp related, would love to hear about it. Doesn't matter what cloud it is. You know, whatever you're doing. If you're using Consul, if you're using Vault, or any of the cool stuff, Terraform. You know, I'm a big fan of that one. But it doesn't have to be Azure. It can be whatever you want it to be. In fact, I'm even gonna mess around with what is Ned's been messing around with that. Was that Proxmox?
Proxmox. That's
Yeah.
like basically a replacement for VMware.
Yeah.
Yeah.
Like I'm gonna try that on my home server rack. So I might be.
Yeah, because Broadcom pissed off everybody by taking away.
Hey, let's not start any international incidents.
No. I'm just saying
okay?
they made everyone mad by taking away the free version of ESX.
Yeah,
or
yeah.
VMware. So everyone's looking for basically a replacement for that. So
Yeah. I've just had enough controversy, so I'm trying to stay away from controversy.
yeah, for sure.
So I'm doing a webinar for the AWS Marketplace. I think on May 15th at this point. It's EKS, TFC, and New Relic. If I get that done by May 15th, I can do the June.
Amazing. Okay. Yeah. Get you in for June. Sweet. Yeah. All right. Well, hey, thank you, Brian.
Cool. Yeah.
Yeah.
Thanks.
Thanks, everybody. There's a lot of pizza, so check it out. And thank you, everybody, for joining online. See you next time.
If anybody wants to take pizza home, I believe there are 3 cool pizzas that nobody touched.